Hey, it's Eamon with ipXchange coming at you with our first ProjeX interview. I sat down with Isam from Chili.CHIPS the other day to what I was hoping to discuss is the evaluation of some of the technology that Chili.CHIPS has got through ipXchange. But Isam wasn't actually part of that process. So instead we had a very, very interesting discussion of how he basically designed neural networks on an FPGA. Yeah, this perfectly slots into what we've been talking about at CES. Prepare for a very interesting, thorough, in-depth interview with an engineer himself. Hey, it's Eamon with ipXchange. We're filming our first ProjeX interview. So I've got Isam here from Chili.CHIPS, and we're going to have a chat about a problem that he had in the development and how he solved it. So Isam, welcome to ProjeX, and yeah, tell us a little bit about what you do at Chili.CHIPS.
Thank you for the introduction. So I'm Isam Vrce, freshly graduated and I got master's degree at University of Sarajevo. So I'm really enthusiastic person, and I like to forge new friendships. And my academic, in my academic pursuit, took some really good turn when I met founder of Chili.CHIPS, and with him we formed some club at my faculty of electrical engineering, and that club is FPGA. It's in my language, in English probably will be ATFPGA, I don't know.
Okay.
And there we do some fun stuff. We do some things about electronics, PCBs, FPGAs, do something with picture, images, sound processing, and we are trying to make some, and we are doing some RISC-V processor. We are
Okay.
trying to make RISC-V processor, and some projects we are involved are Tetris Sarai. It's Tetris, classical Tetris, but in a fun way.
Okay.
It's FPGA based, and it's probably very interesting for us. And there is another project we are venturing into, open source project, and we are doing some
Okay.
trustable image sensor gateway, and it will be open source, and we try to incorporate. We are trying to make FPGA based camera with camera. It will support a lot of camera sensors, and it will be camera system, let's say like that. It will be all open source.
Okay. So in terms of uh, learning to program FPGAs, kind of how did you start, and what are the challenges that you really faced, and what specific FPGAs are we talking about?
Okay, so uh, we are doing with low level FPGAs. I think
Mm.
it's because below 2000 lookup tables and small
Okay.
DRAMs. And regarding my project, my master thesis,
Mm.
let's say, so why that project happened. So imagine you are in an elevator. So my project was trying to speech recognition with
Okay.
FPGA, keyword recognition in FPGA,
Okay.
but in Bosnian language. So
Okay.
imagine you are in an elevator, and you have hands full of bags, and you are trying to reach to one specific button to go to seventh floor, and it's literally impossible to do with your own hands.
Yeah. Yeah.
So if you can basically say, go, let me go to seventh floor or something like that, or imagine struggle of people with disabilities every day trying to do something like that. And that's when my idea clicked. I want to make some keyword detection for elevators, home automatization, or
Okay.
basically anything, but in Bosnian language. And someone would say it's not big deal because that's already there is a lot of final products doing like that, but I need to emphasize that this is in my language, Bosnian language,
Mm.
and which is speaken with fewer of 5 million people, and it's not like English, German, or Chinese, where solutions are
Uh,
already there.
yeah, very
I need,
specific. Yeah.
yes, I need to gather some information and do stuff on my own, let's say like that. So that's
Cool.
why my project happened when my project.
So, I mean, I'm very interested in languages in general. Are there any specific things in the Bosnian language that you don't find in English, for example?
So there is a lot. So we have letters like ch, j, j, sh.
Ah, so yeah, they're
They,
quite
they,
similar.
yes,
Um,
it's quite similar, but it's in reality it's a
yeah.
different. It means different words. For
Mm.
let's say like that.
Ah, interesting. Cool. So in terms of, did you choose to do this with an FPGA because you were already familiar with FPGAs, or is this
Quite
is
the
this
opposite.
yeah? Okay.
I was familiar with embedded with microcontrollers and C and C++,
Okay.
and on when founder of Chili.CHIPS reached, he proposed FPGAs and system Verilog, and so we use a modest FPGA. I decided to use modest FPGA with only 9,000 lookup tables and really small DRAMs, but I want to I wanted to squeeze as much possible as I can
Mhm.
because that's my goal. And besides that, I've used two other external hardware components.
Okay.
It was FPGA, then audio codec, which will receive my which will receive my speech and convert it from analog to digital, and then
Okay.
send it to the FPGA. And there is LCD screen where the final recognized word will be printed out, so person
Okay.
can see which. It's a prototype, so it's a stepping stone for my colleagues to enhance that in the future, I hope.
Okay.
So besides that, there is some interesting thing because everything was, let's say, invented, but it's not invented, crafted. It was crafted from the scratch. So I to C communication, I to S communication, every block in the FPGA besides FFT, because Govin provided better
Yeah.
FFT than me, and even the character set for the LCD screen, everything was created from the scratch. And the funny part is that I2C, I needed to interact with audio codec quite a lot, and
Mm.
I make my own programming language in Bosnian, which translates my human understandable
Okay.
commands to the machine code that will be on the DRAM on the FPGA, so I can program it with ease. Let's say like that. It was I.
Wow.
So
Yeah.
the name on the of the programming language was I2 Cever, because my name is Vrce. It was I2 Cever. So
Oh, nice.
it's something to.
So, I mean, you said that you started in the microcontroller space and then went into FPGAs. I mean, I've got a very little bit of experience with programming microcontrollers just by playing with like Raspberry Pi Picos and Arduinos. But I did try and do some FPGA programming, and it was just such a different world. So how did you kind of do you have any tips for anyone who's kind of going from microcontrollers to FPGAs of how best to learn that new kind of way
So
of thinking?
okay, so it's for me it was a really different way of thinking.
Yeah.
Probably I'm not really experienced now, but I gathered some experience during my project, and I saw that even though I program it on the FPGA, I first created some code in higher level
Yeah.
languages like Python and MATLAB. Then I use fixed point a presentation of the algorithm in that higher language, and then I tried on the FPGA, and using simulation and logic analyzer, I compared the results in my FPGA design and the fixed point in the uh, Python and MATLAB, and I compared the results. And if I see it's a big difference, then I iteratively try to enhance the procedure. One thing to what was hard to me to when what was hard to me when I was programming the on the FPGA is that parallelism. And when I compared some things on with microcontrollers and FPGAs, and FFT calculation was like 10,000 times faster. I think it's that number when used on regular C without any multi-threading or something like that. That just implementation of C in that and on the FPGA. Maybe it's thousand. I just forgot
Yeah,
the exact numbers, but really
it's
big
much
difference.
faster.
Yes,
Yeah.
and I wanted to squeeze that parallelism as much as I could during
Okay.
programming in system Verilog. Yes.
Okay. So when uh, from what you've said about it, it sounds like you're at a prototyping stage. So how is it working at the moment? Are there any bugs that you had when you were developing that? Or what were the solutions for those bugs?
A lot of bugs. A lot of bugs. First of all, I need to emphasize this. So I didn't have any data set to start with. So I
Ah, okay.
make some MATLAB script, and I send it to my friends, colleagues, everyone, and they interview their family to gather information.
Oh, just so that it has the idea of being able to understand Bosnian speech. Is
Yes,
it?
in
Okay.
Bosnian, they say they are
Yeah.
saying words in Bosnian. For example, zdravo, upali, uključi, it's words in Bosnian, and they speak those words, and they are gathering information for me. Then it was time to process all those information and get the usable data from it. Because if you sample audio at 8 kilohertz in just 1 second, you will have 8,000 data. So
Yeah.
I use some feature extraction, which I used as mel frequency capture coefficients, MFCCs, and it was really interesting to implement those on the FPGA. I'm not sure if I'm answering this question right now, but I will get there. So uh, when you try to implement MFCC on the FPGA, it's really tricky because when you implement those on the in the floating point on the MATLAB, you have or Python, you have function that do everything you want. But when you need to go to the register level, it's hard to balance between accuracy and uh, resource efficiency.
Okay.
I recall that this is not only 9 lookup tables. So I used 16-bit for 16-bit for representation of some internal structures, data structures, but sometimes it was Q88, sometimes what was Q12.4. It's really delicate to work to to try to have as much accuracy as you want, but small resources. I'm not sure if I'm answered question. I
No,
forgot about
no,
it, but
no. I know. Yeah, I think that's a good answer. So, I mean, this is quite an interesting thing because there's so much talk about kind of machine learning and training, but from what I gather, this is mathematically figuring out what's being said, is it?
okay,
Or
okay.
or is this where does this type of audio processing differ from kind of machine learning training?
Okay, so
If you know.
I did use machine learning, and but in a way that I trained a neural network in the Python,
Okay.
and then when neural network was trained, I used the weights and biases of the neurons, uh, and from floating point go to the fixed point, and then all those biases and weights, I imported them into memory of the FPGA, and then
Okay.
implement from scratch neural network on the FPGA side. So model was trained on the in the Python, and then in forward propagation was done on FPGA.
Ah, okay. So I'm really, really glad you explained that because because we've been posting lots of stuff from CES and there's so many different AI chips that are coming out, and it got to the point where we were trying to figure out, is this just maths or is this machine learning? And some of these people were saying they have AI where we were not sure if they did, and some people were kind of saying, oh, it's just that, and it seemed the same as AI. But it's very interesting that that this. I mean, I don't want to put words in your mouth, but would you say that this was a machine learning application?
I'd say
In
it is.
Yeah.
It is.
Okay.
So I, I know that there is a lot of keyword recognition and
Hmm.
speech recognition stuff, but some of that they use large neural networks, and it's on cloud. The
Yeah.
idea behind this, it was all on the FPGA, and privacy is guaranteed because there is no connection to the internet. So
Yeah.
everything is on the FPGA, and those neural net structure of neural network is on the FPGA.
So we've just had a moment of technical difficulties. We will resume the interview imminently. So I wasn't expecting that we'd get into this within the conversation, but you're about to say something to do with your experience of doing this machine learning task. Was that right?
So overall, I think that everything when you try to do on the low level, everything becomes harder and harder. So
Yeah.
on the low level, it's on the transistor level, and some things that you can't imagine will happen, and some wire goes pop up, and you lose everything, and it's a bit, and that is where uh, I would like to my colleagues go to will go in extend my project, and I hope they will make some PCB design where we put all those three hardware because it's a mess. It's a really mess, but when you need to wire up three separate hardware components into
Yeah.
one piece, and it's wires everywhere. So I hope they will make some PCB design that will be some form factors to others to try everything out.
Oh, excellent.
Maybe
Um,
use maybe use better FPGA, and use some other techniques, and do better than me. I don't know.
okay. So actually, that's an interesting question. Is that so? You talk about better FPGAs. So how different is it programming different FPGAs, or have you only programmed one type of FPGA?
I've programmed two types,
Okay.
maybe two types. I'm programming Xilinx FPGAs and Govins FPGAs.
Okay.
So they are, for me, they are similar. Some things are better than on the other on one side, some of other side. Some are faster building, generating bit stream, and all kinds of stuff. But for me, code is code, logic is logic, and
Oh,
when
fair
you have
enough. Okay.
logic to do something, it's easier. For example, I didn't know a lot of programming in some languages, and in the 5 to 10 days, I got really, I think, good at it, because the logic behind it is, it's everything is math, I say.
Yeah. Sure, that's a quote. Everything is maths, but I
I'm not
can't
sure.
remember from who.
Maybe I don't know.
I'm sure we can look it up. It sounds like it should be a quote. If it's not, we're quoting you.
Yes.
Um, in terms of the future of the project, where do you kind of see it going? How would you expand it?
Okay, so the one way of expanding it is to I'll try to go to my at FPGA club, even though I
Mm.
finished my degree,
Yeah.
my studies. I'll try to go to them and to convince them to enhance data set. If we to, in this stage, data set is really small and recognition is 10 words. But if we would have some greater data set and maybe we use better FPGA, I don't know, maybe we
Okay.
will try and do things better and maybe help uh, people with disabilities. And one way of thinking about it, if someone can't hear right or can hear right, you could speak to that device because it's
Mm.
FPGA and battery consumption isn't really big. So
Mm.
that person can work with the device and someone can say to them some words. As for example, you go to hospital and in hospital there is 20 words that can go navigate to the hospital, let's say.
Okay.
I'm not really into the terminology, but 10, 20, 50 words is okay. And people
Mm.
with that kind of disability can reprogram the device to recognize those 50 words and they can navigate to the hospital or pharmacy or
Okay.
I
Yeah.
don't know where. I know that there is no big company behind it, but I hope not a company, not uh, maybe you will cut this. I I don't know
Funding.
funding. Yes, I
Okay.
don't know if
Yeah.
I don't know if there is that I know that there is not really big funding behind this, but I hope that we will go somewhere with it.
Excellent. Well, thank you for sharing that project. That's such an interesting chat, and I think actually, strangely, meshes perfectly with some of the stuff we're posting on the other side of ipXchange. So thank you so much for sharing that. What's in the future for you?
In the future, so I'm currently doing that open source project.
Yeah.
I will send you all the links if you want it,
Yeah. Yeah.
and
Sure.
I have a lot of links, let's say, and I will send it to you. And we are doing some open source projects, and that's future for me for now.
Mhm.
I would like to mm, my when I was young. I always told my parents I will do good things for the humanity. It was child's wish, but I think it's came uh,
Yeah. It
through.
sounds like you're doing well.
Yes, and I have you said something was quote, and I have some saying, let's say,
Oh yeah.
uh, to say, and I prepare it for this. I will read it.
Yeah.
So
Yeah.
and remember, a river is a mere spring at the start of its journey, and it's not guaranteed it will become an ocean at the end. So you need to do stuff hoping for the best.
I think we'll end that there. That's a perfect ending. Thank you so much, Isam. That was a really, really good interview, and I wish you all the best for the future. So, everyone out there in the audience, check out Isam's open source projects, and yeah, hopefully we can hear some updates on what the FPGA club is doing with regards to this Bosnian speech to text device, because it's such an interesting project and could do a lot of good. So, if it wasn't obvious from how I ended that interview, I was absolutely blown away by my chat with Isam, and yes, I wasn't expecting that level of detail, and especially I wasn't expecting neural networking on an FPGA to be the main topic of discussion. So if you'd like to implement a similar type of workload, there's a few different FPGA solutions that ipXchange was written about, so you can check them out on the FPGA board page. Keep designing.
Hey, yo, where my engineers at?